Okay, this is an extra example that just needed to be added after a live session. So I want to go back and talk about a couple of things about Pythagorean triples in general. So we had this like big long list, and the Pythagorean triple, obviously three different numbers in it. The biggest number is always the hypotenuse. So like for this one, the 145 would be the hypotenuse, the 181 would be the hypotenuse, and so on. But between the other two sides, those are called the legs. They're like the non-hypotenuse sides of the triangle. There's always one odd and then one even. So odd, even. Um, Over here, like the hypotenuse is 145, and then in this case, like the smaller one is odd, or sorry, the smaller one is even, 24. The like longer leg is odd. So we have to be careful and kind of check that when we're using Pythagorean triples to solve for x and y. So in the examples that we've done so far, if we look at example 2, the hypotenuse was the 65, and then the like longer leg, that was the even one, and the shorter leg, that was the odd one. So I made a mistake in kind of always labeling the first one A, the second one B, and pairing it up with this A and this B. That's not always the case. So there's a couple times that or a couple things we just have to be careful about when deciding, which number goes with A and which number goes with B. So this next example is going to kind of show that. So example 3, use the Pythagorean triple 96, 247, and 265 to find the values of x and y. So this is the Pythagorean identity right here. The longest leg, and just remember this is like my a squared plus b squared equals c squared of the Pythagorean theorem, and then of course a is x squared minus y squared. This like power is just a part of the formula for Pythagorean theorem. And then b is 2xy, same thing, this power just goes along with the formula. And then c is x squared plus y squared. And then that squared, like kind of outside the parentheses, is just part of the formula. So when we're deciding, what what values from the Pythagorean triple go where, the longest side, in this case 265, that's always c. But between the other two, it's not always A and B. So it's not just first one A, second one B. So we have to look at what the factors are. So like in this case, this is x squared minus y squared. But what we have to really pay attention to is this is a 2xy and a 2 times x times y, because a 2 is a factor there, always has to be even, no matter what. If 2 is a factor, it has to be even because 2 times any number is even. So out of the remaining 2, so we know this is C. And then out of the remaining 2 numbers right here, the even one has to be B. So then this would be B because 96 is even. And then the odd one would be A. And there will always be like one even and one odd. There won't be like 2 evens or 2 odds. So just keep that in mind. The even one has to be B. That would go with the 2xy. So now when we're setting up our equations, our first one, do x squared minus y squared. That's for A. So x squared minus y squared is equal to our A value, which was 247. And then for B, that was 2xy, and our B was 96. And then for C, the little like expression was x squared plus y squared. And then the value of C, that's always the longest side from the triple, was 265. Okay, so kind of like the order that you would, I guess, like place your A, B, and C in is I would always just start with the longest side. So make the longest side C because that's the hypotenuse. And then between the 2 remaining sides, you have to look for the even one. The even one would be B because it has to if there's a factor of 2 like we have right here. And then the odd one would be A, regardless of which one is bigger. And then now right here we have a system. So we can use that system to solve for x and for y. Just take 2 equations out of the system. It's usually going to be the equation for A and equation for B. They're going to be like the easiest combination. And we can solve that system usually by elimination. So you can pick whatever solving method you want between elimination or substitution, but elimination is usually like what it's set up best for. So the first equation, x squared minus y squared equals 247. And then what was my third equation? So x squared plus y squared equals 265. And then for elimination, that's when we either add or subtract the two equations. So since these y's are opposite signs, but the same coefficient, just one is positive one, one is negative one, we can add the equations together. And then we just go left to right. So x squared plus x squared would be 2x squared. And then negative y squared plus y squared, that just cancels out to 0. So I just cross that off. And then equals 247. And then 247 plus 265 is 512. And then from there, my goal is to get x by itself. So I would divide both sides by 2. And then 2 divided by 2 is 1. That goes away. I'm left with x squared equals 512 divided by 2 is 256. And then I need to get x completely by itself, so I'd have to square root both sides now. And then square rooting it cancels out the power, and I'm left with just x equals, technically if you square root 256, it should be positive or negative 16, but x and y have to be positive integers, so we would just do positive 16. So that's my x value. And then I use that x value to solve for y. You could pick any of the original equations to solve for y, but usually the second one is the easiest one, the one that just has 2xy ends up being the fastest, but you can pick any one that you want. So I'll rewrite it up here, 2xy equals 96, and then we just found that x is 16, so I'll put the 16 in there. So 2 times 16y equals 96. I can multiply the 2 and the 16 together to get 32. Y equals 96, and then the goal is to get y by itself, so I'm going to divide both sides by 32. And then 32 divided by 32, that cancels out, so I'm just left with y equals 3. So x equals 16 and y equals 3 would give us that Pythagorean triple.